Now let's talk about another important concept, right, where I've seen many people struggle. Let me write it down. This is concept 2. Okay. And this is called product constancy, right? And then we'll talk about product constancy and some of its variations, or in fact, there's only one variation to it. We'll talk about it. But what does product constancy means? As the term states, product constancy simply means the product of some terms is constant, right? And usually when we talk about product constancy, at least from a CAT perspective, you're only talking about two terms, right? Only two terms. So it means that the product of two terms is constant, which means that A into B is constant, right? So if there are two numbers, A and B, their product is AB, right? And AB is constant. This is what product constancy means, right? Right. So for example, 4 into 2 is 8, right? 1 into 8 is also 8. Okay? So the product is constant. This is what we mean by product constancy. So are you guys with me? Do you understand what is product constancy? Okay. Now we'll see how to use product constancy. Okay. I'm just removing this example. I'll write it again. Okay. So let us say there are two numbers, A into B is constant, which is AB. Now if somebody says that I increase A, right? What should happen to B? What should happen to B? B should decrease, right? Because the product is constant. Similarly, if I decrease A, B should increase, right? There's no other way for the product to be constant. If one is increasing, the other has to decrease and vice versa. The problem is if somebody says that I increase A by 25%, by what percentage does B decrease, right? Now there is a formula for this. I would suggest don't use that formula, because the formula is valid only in the case when product constancy happens. When I talk about a variation of this, that formula will go away, right? So just try to understand the concept. We'll figure out. First, we'll talk about the fundamentals of it, and then we'll see how to do it quickly. Okay. So let us say I increment A by 25%. So I introduced you the previous concept where I said if a number is increased by 25%, it becomes 125% of itself, right? So can I write that A becomes 5A by 4, right? I can write this. 5 by 4 is 125 by 100. So A becomes this. Suppose B becomes B dash. I don't know what B dash is, but I know that the product is constant, which is still AB, right? A cancels with A and B dash comes out to be 4B by 5, right? As told to you intuitively also, B has reduced, right? When you increased A, B has reduced. That's why the product remains constant. Now, if somebody asks you percentage reduction in B, so what is percentage reduction? Percentage change. So percentage change is final minus initial upon initial into 100, right? Unless otherwise mentioned. If he wants to if the examiner wants you to calculate the percentage change with final as the denominator, then that's a separate thing. But unless otherwise mentioned, this is how you calculate percentage change, right? So what's the percentage change in this case? Final is 4B by 5. Initial was B divided by B, which is again initial, multiplied by 100, right? This is minus 1 by 5 into 100, which is minus 20%. Correct? Are you guys clear on this? How are we getting this? This is the very fundamentals of it, right? Why is this thing happening? If you know nothing, you can use this method, right? Because this is the very basics of it. This is the very crux of it. This is everything from where every other concept, Like this is the very source from which every other concept or every other formula is coming out, right? Are you guys clear on this? Fine. Now let's try to see what could be a better way to solve this, right? So let's try to see a faster method. Let's see what is happening. Let's see what is happening, right? A into B is AB, fine, right? Now this becomes 5A by 4. So we are discussing only 2 or 3 concepts here. I discussed the basics of percentages. Now I'm discussing the product constancy part. Then we'll talk about the idea of successive changes, and then we'll do a few questions on these 2 concepts. So that's the brief background of the seminar. So 5A by 4, right? We said it is becoming 5A by 4. Now notice, to have the product as constant, right? Notice this. This is 5 by 4, right? And here it is 1 into AB, right? So what do you need to multiply here? The only thing that you can do is multiply the coefficient of B, right? What should be the coefficient of B? The coefficient of B should be such that 5 by 4 multiplied by that coefficient is 1. The product of 2 fractions is 1. That means they are reciprocals of each other, right? So the only way you can do it is 4 by 5. There is no other way possible, right? So what do we learn from here? We learn that actual value of A, actual value of B, actual value of AB is not of importance to me. What is of importance to me is this new coefficient after the increment, right? This new coefficient after the increment, which is 5 by 4. The moment I know this coefficient is 5 by 4, I know I need to multiply it by the reciprocal of it to get right hand side is the same, right? To get right hand side is the same. Because if you divide these 2 equations, look at it carefully. If you don't know this, right? If you divide this equation, then basically what you're getting is right hand side is 1, right? Right hand side is 1. A, B, everything will cancel out. That is not of importance. The only thing that is of importance is this coefficient, which is 5 by 4. That's why the moment I know this coefficient, I know I have to multiply it by the inverse of it or the reciprocal of it. And that's how you can do it very quickly. Okay. If it is clear, then let's quickly see another example. Okay. I'm just constructing these examples on the fly. So let's see another example. Suppose there are 2 numbers again, right? These 2 numbers could be anything. Like this is a concept, right? This concept can be used in time, speed, and distance also. If you increase the speed by a certain percentage, by how much should the time be reduced so that the distance traveled is the same, right? That's why this is a concept. It can be used in many places. Nobody's stopping the cat paper setter to use this concept in DILR, right? Very simple concept. Product of 2 numbers is 1 only when both of them are 1 or they are reciprocals of each other, right? Very beautiful concept. So let's quickly take a look at another example of this. Suppose rather than incrementing A, now I decrement A, right? Suppose again there are 2 numbers, A and B, the product is constant. Suppose A is decreased by 40%. Find out the percentage increase in B. Again, product is constant. So if A is decreased by 40%, we know that A becomes 60% of itself, right? So it becomes 6A by 10. 6A by 10 is 3A by 5. The moment I know 3A by 5, I know B will become 5B by 3. That's it. I'm done. B will become 5B by 3. Now you just have to find out the percentage change in B. 5B by 3 minus B upon B into 100, right? Which is 66.67%. right? 66.67%. What was more important for me was to figure out what this coefficient is. The moment it was 3 by 5, I knew B will be 5B by 3. That's it. Right? And I have become so habitual of solving questions that for you, you might need to do this, right? But the moment I know that it changes from B to 5B by 3, I can instantly write 66.7%. So it's like a matter of 5 seconds for me, right? But this concept will help you reduce a lot of time.